All right, so here's some more graphing by transformation. So again, we're talking about exponential functions. We're talking about growth and decay. We first talked about just making a table of values, plugging in points, and putting the points on the graph paper. And then we started talking about transformations. So we're going to continue the last video. We're going to basically just continue that same process, except now look at exponential decay. But we want to practice the same things we were just doing. So here we have an example with everything in it, right? So if we think about our general form of the equation, our exponential equation, then we look at the h and k values. So I'm going to put everything that we know up here. We know that our a value is 5. Our growth or decay factor, b value, is 2/3. Our h value is 2, and our k value is 3. So what we're going to do is we're going to graph just the y equals ab to the x function, right? We're going to ignore the h and the k translations for now, and let's just think about what if we had 5 times 2/3 to the x. We're first going to graph that, and we're going to get 2 key points from that graph. The 2 key points are going to be plugging in x equals 0 and x equals 1. If I plug in 0, you can just look it up. I know I'm going to get the a value, which is 5, right? If I plug in 1, I'm going to get 5 times 2/3, which would be, I guess, 10/3 there. Or 3 1/3. I'll just put this as 3 1/3. Okay, so there is my 2 key points that I'm going to base everything off of, right? So 0 goes to 5. 1, 2, 3, 4, 5 is right up here. And then 1 is 3 1/3. Now some of you might freak out and say, oh, I have a fraction in there. That's totally fine. We're just going to graph it and approximate 3 1/3. So 1, 2, 3 1/3 is about right here. We also know that this graph is going to have an asymptote at 0, right? It's always going to be 0 if our h or k value, or if our k value is 0, which is kind of what we're assuming for this first graph. So my asymptote for this first base graph is at 0, and if I were to sketch this first graph, it's exponential decay. I got these 2 points that I'm referencing, and I know it's just going to continue to get smaller and smaller and smaller, and then going to the left, it's going to go up and to the left. Okay. Now I'm going to finish my graph by translating these 2 points left, right, and then up, down. So what are my 2 new points? Well, my 2 new points are going to be given from the h and the k values. The h value up here is going to be a shift to the right. It's going to be shift 2 to the right. And my k value is going to be a shift 3, and it's going to be up. It's going up. So my h value is going to change my x's. So this 0, 5 point right here is going to change to 0 is going to become 2, because I'm going to add 2 to that number. 0 plus 2 is 2 because of the h value. And then my y value is going to increase by 3. So 5 I start with, but the k value is 3, so I'm going to add 3 to that. Everything is shifted up, so that's going to become an 8. If I look at my second point, the 1, I'm going to add 2 to that to make this 3, and then I'm going to add 3 to this to make this 6 1/3. So these are my new points, right? My shifted points, okay? Just my left, right, up, down shifts. So again, let's look at the visual. I'm going to show the visual, and the numbers that we got should map up to exactly what we have over here. So I start with the 0.05, which is right here. Okay, you can see the function in gray. There's my first point that hasn't been translated. And I'm going to move to the right 2 and then up 3 because that's what my h and k say. Right 2 and then 1, 2, 3, up 3. Which of course should match up with what I already did, which is at 2, 8. This is at 2 and then goes to 8. Next point, which is right here, originally was at 1 and 3 1/3. I'm going to shift this over to 1, 2, and go up 3. 1, 2, 3, right there, which should be at the point we already knew was going to be at 3, 6 1/3, which it is. The other thing is this asymptote right here. Here's the asymptote, the boundary, which is always kind of at 0. But since our graph is shifted up 3, I'm going to go ahead and put my asymptote at 3. Oh, something messed up there. Let me try that again. So I have y equals 0, and then the asymptote's going to go up to 3. So 1, 2, 3. So that blue part is the new boundary line that I'm using, the new asymptote. So now I'm going to finish this graph. I have my 2 points that I'm going to use as my reference, and I know this is just going to basically decrease and follow along that asymptote at y equals 3, and it's going to increase up and to the left. So my answer here is basically the red graph, right? It's this red graph going through, but we're using the gray graph, right? Basically the graph that we start with, but without the h and the k, to get just a first picture of what the function looks like. And then we use our h and our k value to translate those points left, right, up, down, and then we get our final answer. All right, so we're going to go ahead and practice that one again. So if you want to pause the video, you can go ahead and try this one on your own if you want. Otherwise, you can keep watching. So here we have another function, and what I'm going to do here is actually, I'm going to change this to plus 2. So we have another true exponential decay function. So the function is 2 times 0.75 raised to the x minus 2 plus 4. So I'm going to go ahead and look at my general form of the equation, and I'm going to write down all my values just so I can do that. So a is equal to 2, my b value is 3/4 or 0.75, which means I'm going to have exponential decay here. My h value is positive 2, which is going to be a shift to the right 2 spots. And my k value is positive 4, which is going to shift up 4. All right, so what are we doing first? We're first going to graph the base function without the h and the k involved. Right? We're going to assume that h and k are just 0. We're not even going to worry about that. So we're going to be looking at y equals 2 times 0.75 to the x. Right? The same function that we start with, and I'm going to grab 2 key points from this function right here. The 2 key points, I'm going to start with 0 and a 1 for my x values. If I plug in 0, I always get whatever my a value is, which in this case is 2. And if I plug in 1, I'm going to get basically 2 times 0.75 to the 1, or the a times b value there, which is going to be 2 times 3/4, which would be 6/4. And so this is going to be 1.5. And I know the asymptote is going to be always y equals 0 because my k value is 0. So I'm going to put all that in. I'm going to first put in my asymptote, which is at 0. And then I'll put in my 2 key points, which is at 0, 2 right here. And then at 1 and 1.5. 1 and 1.5. So those are my 2 key points here. Not a lot of points for the graph, but we're just using those 2 points to demonstrate the transformations and the patterns that we're using. So this is exponential decay, which I know is just going to go down and follow that asymptote, and then it's going to increase up and to the left. So it might not be perfect, but it's just a sketch. Now I'm going to go ahead and add the h and k values. So my new function with the h and k, my 2 points, my transformations, my h value is 2, so that's going to be a shift 2 to the right. And my k value is 4, so this is going to be a shift 4 up. So I can take these 2 points that I have, and now I'm going to basically graph the whole function now. So instead of 2 times 0.75 to the x, it's now to the x minus 2 plus 4, which is the exact original equation. So 0, 2, I'm going to add 2 to the x, so this becomes a 2, and my y value, which is 2, I'm going to add 4 to that, which becomes 6. And then for my second point, the 1 is going to become a 3, because I'm going to add 2. The 1.5 is going to become a 5.5. So there are my 2 new points translated. So again, let's show that visually. I have 0, 2 is my original point over here, but now I'm using my h and k value. I'm going to shift 2 to the right, up 4, 1, 2, 3, 4, which is going to be should be at the point 2, 6. So 1, 2, 3, 4, 5, 6, and yes it is. And then we're going to take the second point that we have here, which originally is right here at 1 and 1.5, and we're going to follow the h and k, which is to the right 2, 1, 2, and then up 6, up 4, 1, 2, 3, 4, which is now right here. So again, you can see that these 2 points, right, together are just shifting right and up, and that's how we're getting our new key points here. The h and the k value is just moving those points. But also note that my asymptote is now going from y equals 0, and since we shifted everything up, it's going to be, we shifted everything up 4, it's not going to be y equals 0, it's going to be y equals 4. So this little asymptote down here is going to go from 0 and also up 4. 1, 2, 3, 4. And there's my y equals 4. And now I'm going to sketch my graph and finish it off. So these 2 points are going to get closer to that line and then trend up and to the left. And there is my new graph. So again, the procedure here is we know our general form. It's right here. We want to be able to identify everything, a, b, h, and k. And then we take 2 key points from this base function right here, which assumes that we don't have any h or k. The h and k are 0. And we use that as our so-called parent function that we're going to base our graph off of. We get these 2 points, and then we use our h and k value, which is our left, right, up, down shift. And now we have 2 new points, which creates this new graph. Everything is shifted up. The asymptote also changes along with it. To finish off here, the domain is all reals, of course, and the range is not y is greater than 0. The asymptote's now 4, so y is greater than 4 there. And so there's my graph. All right, I want to look at one last problem that I saw was in your homework, which is very, very much similar to the graphs that we just did, but it doesn't involve actually graphing, but just kind of doing that process over. So in this problem, it says identify the 2 key points in the asymptote for each transformed function. You don't have to graph this. So just going through the same process here, understanding that our general function, here it is, a times b to the x minus h, plus k. And then just being able to identify a, b, h, and k. My a is -3, my b is 2, my h is -1, and then my k is -4 here. So my base function, or my parent function, is going to be the same thing that I start with, but with no h and k value. So my two key points that are based off of that, right? My two key points are going to be, I'm going to use 0 and 1. If I plug in 0 into this, I'm always going to get my a value, which is -3. And if I plug in 1, I'm going to get a times b. So -3 times 2, which is -6. These are my two key points. And now it says to identify the key points for the transformed function. So now we're going to transform these points using the h and k values. So the h value is -1. That means I'm shifting everything to the left 1. So my x value, I'm subtracting 1 from that. So 0 subtract 1 is going to be -1. And then down here I have 1 to start with, so if I subtract 1, I'm at 0 for that. And then my k value is -4. So that's just subtracting 4 from the y value. Everything is shifting down 4. So -3 minus 4, we end up with -7. And then -6 down here, and we're subtracting 4, we get -10. So these are my new key points on my graph. And we also want to talk about the asymptote. So with my parent graph, or my base graph here, the asymptote is always going to be at 0 because our h and k are 0. Specifically, our k value is 0. But since our new graph, since our k value is -4, the asymptote is going to be -4 because we're shifting everything down 4. So we're going to go from y equals 0 to y equals -4 for the asymptote. So for this problem, my two key points would be that. My asymptote would be y is greater than -4, which also affects their range. All right, so that's it. Just to kind of sum up what we've done so far, we've done linear equations, right? Y equals mx plus b, and we've graphed those, right? That's just a line. We've looked at quadratics, which is a parabolic shape, which can open up or open down, right? And today we're looking at a new function, which is exponential growth or decay. So a times b to the x, if we want to put in those transformations, then we have this. But the idea is that we have something that starts off slow, like compound interest, and increases rapidly, or we have something that starts higher and decreases and kind of levels off there. So some applications, again, we didn't get to those applications today. Anything that increases or decreases by a certain percentage, you're really going to think about exponential growth, like compound interest, like population growth. And we will explore some more of those applications with growth and decay in our future lessons.